So this is the second module which we are going to cover. In this, we are going to understand more about source control, how we can manage the source control, how we can do the operation with the source control, and what are the different ways to manage source controls, and do the check-in, check-out operation, pushing the code to the repository. So those things we are trying to understand in this module. Yeah. So in this module, we are going to understand what is the source control, and but there are different type of source control, mainly the two type of source control which is available in the market, and that we are going to understand about the type of source control. We are looking at the benefits of the source control, what are the benefits we are getting it from the source control, and how we can use our Azure Repos and the GitHub as a source control. Okay, and if we are migrating from the older our TFVC, the control where we are used to have our monolithic application or the old code, we have an option to migrate those into the Azure repos as well. So, and also we have our labs where we'll try to understand how we can go ahead and download our code, and how we can play around, do the changes, and push the code changes to the repository. So that's what we are trying to understand here in this module. So if you talk about the source control, the introduction of the source control says that what is the thing which you can go ahead and do with the source control, and what is the benefit of the source control you are getting it. So DevOps, you can say, it's a kind of software revolutions, you can say, and that has happened for the higher level of control. Like you have, let's suppose that you have a different developer in your team who is doing the code changes, who is doing changes into the code, and what they are trying to do, basically they are not let's suppose that I'm doing a development and I am keeping the code into my local system. Okay, so it's very difficult for another developer who wanted the file or same project to do the changes. They has to come to me and get this file, or somewhere I have to place it in the share folder, then he can take those files. Maybe I have missed to place those files over there, so he will be getting and again old files, and he will modifying those files. So if you have multiple people who is working on the same project, it's very difficult to maintain our files into the common place. Okay, so the source control is giving you the feature where you can go ahead and maintain your source control into the common place. You can go ahead and do the syncing, collaboration, and other things which you will be able to do. You can see the history, that what has changed, who has changed, when it has changed, what was the older version. If you want to compare that, you will be able to compare with the older version. If you want to revert with the old version, you can revert the old version back to the normal. Okay, so that features you will be able to achieve using a source control. So this is the common place where you are going to maintain the code for your project. If you look at this screen, okay, so this is the fundamental practices which you do with the DevOps. Okay, so it is talking about the stages. So from the monitoring, testing stage, the application development stage, application build stage, so all those version control is highlighted here. So there are different places which you can use version control to store the things in the version control. Okay, so if you start the development, so your source control, whatever you have, whatever the configuration you have for your application, the web config file, the configuration file, or any other script file, whatever you are going to write, that you can go ahead and deploy that into the source control, or store that into the source control. You can put your configuration file. Okay, so if you are doing some standardization of your operating system, like I want to deploy something called web app with so and so configuration, or I want to deploy a virtual machine with the 2 GB RAM, or 2 core CPU, something like that I want to deploy. I can go ahead and configure those things, and I can keep those configuration in the source control, so that whenever it's required, I can go ahead and pull those configuration, and I can use those configuration in terms of a deployment. Okay, also if you see here infrastructure, our team uses a version control. So our development team is going to use our something called a configuration team, or the team who is doing the configuration, they are using the also that is used by the infrastructure teams. So you are going to create something called infrastructure onto Azure DevOps. So Azure portal, if you want to create a web app, if you want to create a virtual machine, you can write those ARM template or the custom script or the PowerShell script. Those you can write, you can store those in the version control. Okay, application configuration, or the infrastructure team uses version control. So this is again system configuration and the automation provisioning for the application and the servers. So those everywhere you see, wherever you think that I have can automate that particular step, or I can write a common code to reutilize that. Okay, so that time you are going to use a something called a version control. So there are different steps, different places you can use that version control. So either it is .NET code, Java code, JavaScript, YAML file, Terraform script, whatever you think. Okay, so those you can go ahead and store those as part of a version control, so that other people can look into that and reutilize that source control, but to standardize the process. If you're looking at the what is a source control, so source control basically it is allowing to the collaborate between the developer. So whatever the code changes you are going to do, you can track those changes, you can update those changes into the source control. Okay, source control is providing to look into the history of the code and what are the conflicts has happened. So those things you will be able to see the source control. What do you mean by conflict? Okay, so if you see here, there is a word called conflict, resolve conflict. Okay, let's suppose that I have a code which is available into the server. Okay, and I am doing a changes. This is something called a.txt file. Okay, a file, and again I'm as a user too, that also going to change this file. Okay, so same file is modified by the two person at the same time. Okay, so let's suppose a txt file, and this is my txt file. Okay, so I have taken a copy, and this other person has also taken a copy. This is Ram and this is Shyam, who has taken a copy of the file, and both are modifying the code. Okay, this person has pushed the file before me. Okay, so when I am going to update the file to the server, what happened, the server will say already I have a latest copy available for me. Okay, do you want to replace, or do you want to compare those files? Those things you will be able to do that. Okay, so basically you are going to resolve this kind of conflict using a source control. You are looking at the file, and then you are going to merge that file into the server. Okay, so that kind of conflicts you are going to resolve. Either you download the latest file, then you do the changes, and then you push those changes to the server. This kind of things you have to do it as a in the source control. Okay, so the source control helps you to resolve human error, or sometime of also it gives you something called reliability, traceability. You will be having a maintainability, efficiency. So all those features you will be able to get it from the source control. Okay, so you can reuse, you'll have a traceability, you can do a maintainability, efficiency, you can have a collaboration. Okay, so those things you will be able to achieve using a source control. Now if you look at this diagram, the benefits of source control, what happens in the source control basically. Okay, this is your version control are here, and this is a pipeline. Okay, for the deployment or the release, you can say you are putting a code here. Okay, so whatever the code and everything is there, you are going to push that code to the source control. Okay, now you are going to insert some external package like NuGet package, Maven package, and other things you are going to put into the pipeline, then the build start. Okay, so once your code is ready and whatever the external dependency which is required for your package, you are going to fit in the packages into the pipeline. Now your build process starts. You are going to do a unit test, you are going to do a deployment. Okay, once the deployment is done, you are going to do auto testing. Okay, and then you are going to do a something called a deployment to the production. And finally you are going to measure and doing a validation over there. Every places one thing we get out from the every stage, that is called a feedback. Okay, so every stage we always look for the feedback. So this is one of the important part. We always talk about the feedback into each and every stages. Okay, so either build has happened, then you look for the feedback, what is the log is saying, what how you can improve those log. If you're doing a unit test, you look for the feedback. If you're doing a deployment, you look for the logs and get those feedbacks or the concern from the particular person, and that you are going for the improvement. So this is what we are looking for as a continuous process. Okay, and that's what the benefit you are able to get it using a source control as well. Okay, so you are going to create a workflow and you are working with a different version. You can collaborate with that, you can maintain the history of the changes, and finally you can automate the task from the version control. So basically version control is your you can say your code bible which is available, and that bible you are going to use to build and deploy the code. If your version control code is not correct, everything will go on toss. So this is a thing, a bible which need to be keep up to date, or the latest version should be available over there. Now if you are going to talk about the best practice of the source control, so when you are going you can look at something called merging and doing the commit. You are going to update those code into the source control. So the best practice of the source control we have to follow. Okay, so make a small changes. So make sure whatever your changes you are doing into your application. Okay, you do a small changes, you try to build that, and once the build is success, you push those changes to the source control. If your work things are working fine, you can go ahead and update that change to the source control. And it's saying that do not commit your personal file, so we should not check in that personal file into the project. Okay, make sure your build is working fine. You should try to avoid the conflicts. Okay, so try to avoid the conflicts, else you have to rework on that. Maybe you need to download the code and solve those conflict and fix those issues and upload. Okay, so that you have to do. So verify your code changes before pushing the repository. Ensure your test it's compiles and test is pass. Means whatever the changes you are doing, you are not supposed to push the changes which the build is failing or having a issue in the code. You are not supposed to push, because what happen if you push those kind of changes, the other people who is using or accessing that file, they will get a something called a wrong code, and they also face the similar kind of challenges, and they will also get a error in the code. Okay, so make sure your code is built properly, and that need to be test need to be passed. Then only you can go ahead and push those changes to the source control. Okay, please pay close attention to the commit message. What do you mean by commit message? When you are doing or changing the code, you have to make sure that you give a proper message while pushing the file to the source control. What happens generally when I'm doing some changes, I just write some which is not the meaningful comment. If I write that unmeaningful comment, the other people will not be able to understand what has done in this proper commit or whatever the changes which has been done. Okay, so make sure you are doing a proper commit while doing the changes to the code. Okay, so let's suppose that let's take an example. If I have two user who is doing the code changes into the same file or same project or same class, you can say. So one people if is writing a formula of a plus b, okay, and another people who is writing a formula of a minus b, Okay, so when the people are doing the code changes, he has to write a proper comment that I am doing I'm adding a method which is doing the a plus b. Okay, so I need to write a meaningful message so that other people who is looking at that, he will be able to understand this person has done a plus b already, and I am doing a minus b, so this is the different other method which doesn't conflict with the other code. Okay, so I can go ahead and merge that code, both the codes, and that can be available into the source control. Okay, so that kind of a message or meaningful message you have to always write. Okay, so it should be able, which the other developers or other user will be able to understand. When you are pushing the code to the source control, you can go ahead and link work item. We have seen just now work item. So work item, either it's your story number, your backlog item, your task, anything. Whenever you are doing a commit operation, you can go ahead and link your work item. So for which task, for which user story, or for which you can say that backlog item you have developed these changes, so that people can refer to that changes, and you can say that okay, this has been already deployed, and they can mark as a completed into the work item. Okay, so your project manager or your scrum master can go ahead and update that work item over there. Okay, no matter your background or preference, you be a team player and agree with the convenience of the workflow. So this is just be a team member and work with the team, gel with the team in order to get your things done and follow the workflow and deploy your application. So this is just our best practices which we have to follow. Okay, and this is just we have to remember when you are doing playing around the source control. Now, if you're looking at the source control type, we have seen just benefits of the source control. Now we are looking at the type of source control. So we have two kind of source control which is available in the market. One is the centralized source control, another is a distributed source control. Okay, centralized source control is basically, you can say that we are using before in the past. Okay, what happens in the centralized source control? Okay, centralized source control, and you can see the example of the source control. We have TFVC, you have a CVS, you have SVN. So if anyone of you has worked with this kind of source control, you might have faced this kind of these challenges. What happened with the centralized source control? Your repository are into the common place, a centralized server will be there. Okay, there you have this repository available. So this is your repository onto the centralized server. Okay, I need a copy of this repository to the my local to work, so I'll get the copy. Okay, so I can get a copy to my local machine. Okay, and this is my something called a working copy. I'll be getting it to my local, and what I'll do, I will update from the server. So this is the update operation, and then I will do a commit operation to the repository. So this is what happened, update and commit. What happens here in this problem? Okay, when you are going to change the file. So I want to change something called a.py. So this is my a.py file I want to change. Okay, so I will request this repo to give me the file or a.py, or I'll right click here and update that file, pull the file from the server. So I'm going to update the file, so I'll get a latest copy available in my local. So this file, I got it. I can go ahead and modify. When I'm going to modify, what happens, the lock will start. So lock will be get created. No one will be able to modify during that time this file. Okay, so repo will say that this person has logged this file and he is doing the modification. Till I do the commit operation, the file is logged. Okay, I need to do a lock. Okay, and only I need to commit that file, and only I'll be able to change this file, because I have requested only this file and I am changing this file only. If I want a something called b.py file, What I need to do, I need to again request this repo. I'll get a latest copy and then I am going to modify. So individually granular level of access you are getting it. You are getting an individual file to your local, and you are going to lock that file till you are doing the operation onto that file. Okay. This is, you can see here, and that's what we have to do. And if any case this the centralized server is gone down for the few hours or few minutes, that time you can't get this file. Let's suppose that I'm working on a.py, but I need a file b.py to work on that. Okay, but during that time this repo is unavailable, so I'll not be able to get the file, and I need to wait for the server to come up. Okay, and this is the centralized server, and that is having all the file. Okay, so this is what is called as a centralized. So you can see here, this is the some strength of the centralized server. Okay, so it is good in terms of if you have a large code base. If you have a huge code which you want to store, okay, like a monolithic application, or you can say the huge code base you have, that time you can use a centralized server. Okay, so that you can store all the files on the server. Whoever needs the file, they can get the file into your local and they can do the changes. So that is called a granular permission control. Okay, it permits the something called monitoring. Okay, also you will be going to have an exclusive lock for that files. Okay, this is best used for large file. You can have a file level audit, who has changed and all those things. Okay, it's very difficult to merge that some of the file types which is not supported, or you can say that it's not allowed for that. So this is what the centralized source control. So you can say that this is for the monolithic kind of application. It's good, and this is the example. You have a TFVC, CSV, and SVN. Okay, and if you're talking about the distributed source control, nowadays we are going to use a distributed source control, like we have Azure DevOps, we have a Git. Okay, so GitHub and all, GitHub, Bitbucket, Azure DevOps, so these all works on the distributed source control. What happens with the distributed source control? Now the structure, or you can say the diagram, has got changed here. Okay, now this is what your remote server is. So this is your remote repository. This is your remote repo. Okay, so this is your remote repository. Now what happens when I say I want to get a file? Okay, so when I want to get a file, I will say I want to have a pull operation. So I do a pull operation here to get a latest code, and where the latest code comes, latest code will come to my local repository. There is a local repository will get created into my system. Local repository will get created, and now when I want to get a code from local repository, or I want to modify the file, I need to say I want to get a updated copy of my local repository. So I will get into my working copy, that is called working copy. Sorry, it's a little bit. Okay, so that's fine. So this is my working copy. Okay, so I will get a update here. Okay, now I am going to modify the code here. Once I modifying is done, I am going to push the file to the local repository. So I do here, what I do here, commit operation. So whenever I want to do a changed file, I want to send it to the local repository, I am going to do a commit operation. Once the commit is done from the local repository, I am going to push the file. So there is a push operation which you have to do to push the file to the remote repository. So that's what it is happening. So whenever you want to work with distributed, and one thing you can see, this is a local repo. What do you mean by local repo? Is the complete copy of the file from the remote repository will be copied to my local laptop or desktop, wherever I am going to work. Okay, and then from the local repo I am going to move the file, or when I'm opening the file, that comes to my working folder. I can go ahead and modify. Okay, and then I do commit. Once I done a commit, so code is updated in local repo, and once the commit is done, I can go ahead and push the changes to the remote repository. So this is good for the small code base. So if you have the small microservices kind of architecture, you have a small set of codes, you can use this, because what happened in this case, complete code gets copied to your local system. If you have the GB of the file into repository, this approach is not good, because all the files will get copied into local system, and your space will get utilized. So a strength of this distributed system is you will be able to do a cross-platform support. You have a open source and friendly pull push request you will be able to do. You will be do a completely offline. The feature of the one thing is completely offline as well. Why this is completely offline? Because the complete code of the repository is available in local repo. If I don't have the internet connection in my system as well, or during the travel on the airport, or during the flight as well, I can open my laptop, I can work on the code, I can build the code locally, and I can keep it ready. Okay, once I connect it to the network, I can go ahead and do the push operation. I can commit it locally, and then I can push the once I have the internet connectivity with my system. Okay, you have a complete history. That's why it is called a distributed source control. You can see here the copy of the source control available in the remote repository, also available in the all the developer computer. Okay, if anything happened with the remote repository, I can go ahead completely wipe out, and I can create another repository from my local repository, because my local repository is the same replica of the remote repository. Okay, so that's what you will be able to get it. And the example is the you have a Git, Bitbucket, you have Azure Repos. So all those are example of a distributed system. Sorry, distributed source control. So the benefit, the best to use for the smaller code base. Okay, it's a open source, highly distributed team. Okay, team can work offline, but this is best in terms of a greenfield code base. So greenfield code base, we have seen greenfield from the scratch, like developing a microservice architecture. You cannot use a monolithic kind of application to fit into the distributed system. So large code base and all, you will not be able to work with distributed. So hopefully you have understand this centralized and difference of the distributed. This is one of the important thing which you should know as prospective of examination as well. Okay, so git or whatever you say, the git repo and all that are that is a distributed source control, and TFVC is a centralized source control, which we have to understand. So this is what it has written. So git is a distributed and TFVC is a centralized. Azure repos and all works on the basically on the git standards. So whenever you are going to create a project, you are going to define that you are going to create a git project, or you are going to create a TFVC project. So that you have to select during creation of the project. So you can see here, if you look at the DevOps project, if I say new project, you have an option to select what source control you want to create. So if I'm creating a project, I want to create on the git. So if you're creating a git, then you are creating a something called distributed source control. If you are creating a TFVC, then you are creating something called centralized source control for your project. Okay, so that you have to always think before creating.
Shadab,
Yeah.
I have a question.
Mm-hmm.
Okay, so generally, in which situations do we select Git or TFVC? I mean, centralized or distribution? In what scenarios for a project?
So basically, if as you seen here, for the small code base, if you have the small code size, then the distributed system is best to work with that. So that's the Git project. Okay. And if you have something called a monolithic kind of application, where you have a web application, or you can say the business layer or data access layer, all you have clubbed together as a one project, then you have to go for the centralized repository, so that you can go ahead and store, and you don't have to download all set of code into the local machine. So that's what you have to choose. But now nowadays this Git is a one of the thing which always we look for the microservices. Now the architecture talks about the we have to develop something called microservices kind of architecture. So this always fits into our requirement. Yeah. Okay. So this is what the Git and TFVC difference we have. And so now if you talk about why Git, okay, so we have these are kind of branching strategy first, which you can see the branching strategy which we follow. Okay, so basically we have a master branch. So master branch is a branch where you are going to store your production code into the master branch. We don't touch the master branch whenever you want to do the something called changes. So we follow the branching strategy. I'll tell you this into the something penned. Okay, so I'm just going to talk about something called branching strategy. So this is my master branch. Okay, so master branch goes in the straight direction. This is my master branch. Master branch is a replica, or you can say the copy of your production code. So whatever is deployed into production, you will be going to put into the master branch. Okay, now I need to do a modification into the code. Okay, so whenever you do the check-in checkout, you'll be getting something called head here. Now I need to modify a code. What I will do, I will go and take something called a feature branch. Okay, so I will work on the feature branch. Just now we have created a feature, something called a work item that is called feature and all. So this is I am going to create a take a copy of my master branch, and I am going to create a feature branch. Okay, what do you mean by feature branch? I'm going to implement some changes which has been asked by the my team. Okay, so once I'll take a copy of this and I do the development into the feature branch. And once this feature branch is tested, okay, and code review has happened, okay, so there will be a code review will happen. So code reviews happen, and you are going to merge the code. So you are going to raise for the code review, and once the code review is done, basically you are going to merge back and the code is deployed to the production and everything is done. Then you are going to merge that to the master branch so that your master branch is up to date. So any development which you are going to do, that development you don't have to do into the master branch, because you are not going to touch the master branch directly and modifying the code into the master branch. You always make a copy of the master branch. Either if you want to do something called development, then you can create a something called development branch. You can make it a development branch. You do the changes into development branch, and once you are fine, tested everything, you just say that I want to create a pull request. So you create a pull request. The pull request goes for the review for your architect or the whoever the team lead is there. And once they're happy with that, then you are going to update to the production, and finally you merge that code to the master branch. So this is what it is called as a branching strategy. So if you just try to Google that as well, something called Azure DevOps branching strategy, you'll get so many documentation for that as well, what branching strategy we have to follow. So use feature branching. So these are the things you have to remember, and how you can go ahead and use that. Release branching. So from the main branch you are taking a feature branch, from the feature branch you are taking a hot fix or the bug fix branch. Again you have something called feature, and another thing you are going to merge back. So this is what you create a new feature branch from the main branch, and you do the cherry pick on the branch, and finally you merge those things. So there are a multiple branching strategy. Also you can see that there is a video is available here, so that you can always look. So what a branching strategy which is good in terms of the development. Basically generally we use this feature kind of branching strategy into our organization. So this is a very frequently used. Okay, and in this branching strategy you just create another parallel branch, you do the development, and finally you merge back to the master branch. So this is the branching strategy which you can always refer. This is the thing you will be able to do it here. So you have something, you can create a feature branch, you do the development into the feature branch, and you merge back to the master branch. Then you have a distributed, the Git is a distributed source control, where you have a full repository available, also the copy of the full repository available into the developer system as well. So wherever you take a copy of the full distributed system, a full copy is available. So that's what it is called, a distributed source control. Okay, so you have a copy of the code available into the each systems. Okay, then you have to create something called pull request. So when you are doing a development to the feature branch, I just now told you the pull request. So when you are saying that I want to create a pull request, means it will go for the set of approval. So in the feature branch, let's say you have made a changes in the code. Okay, that code you want to push to your production, or you want to push those changes to the different environment. Before pushing the to the environment, you are going to create a pull request, and pull request goes for the approval, means your architect, your team lead, or whoever the expert into your project, they are going to look into the project. Okay, they are going to look into the code, and they are doing the code review. You can have a 2 or 3 person who can review the code, and they can approve the code. Okay, and once the approval is done, then only you are going to do a build or release a task which you are going to perform. Okay, so the other peoples are also involved in terms of a pull request. So that's what the pull request means here. And another thing, you have something called community. So this is a completely community driven, it's completely free to use, and you can also go and contribute into the different GitHub, or you can go and deploy your if you have something, another feature or another topics which you want to share onto the GitHub, that we can go ahead. Also you can go ahead and publish your projects into the GitHub. Those things you will be able to do using Git. Okay, and then you have something called release cycle. So whenever you are here, you are going to release a product to the customer. So customer is using a product, and you always look for the feedback. So that's what the benefit we have to use with the Git, and that's what we are going to learn with the Azure DevOps, how we can utilize this, all the feature of the feature branching, distributed source control, pull request, how we can use a release cycle and all. So that's we are going to use using a Azure DevOps. Okay, if you're using something called Git, okay, so you can make a copy, like you can use a command prompt. So Git is your you can say the SV, your Bitbucket, your GitHub, your Azure DevOps all works on the Git. So distributed branching and all, it works. Okay, and also it talks about now Git also supports your large file system. So if you have a large binary file which you want to upload into Git, nowadays Git supports, because there is something called Git LFS supports is available. So large file is also available here. So this is objection to using a Git. So the people says that that overwrite history. Okay, that doesn't support large file. You don't have a proper learning curve or those things. So but these are just objection, you can say. Okay, but these are now getting resolved with the Git. Okay, and Git supports all those things as well. Okay, now if you're going to talk about, now we are moving towards the something called introduction of Azure Repos, and what we have with Azure Repos. So Azure Repos also works with the Git. So we Azure Repos supports both things now. So Azure Repos supports Git as well as TFVC. So the Git supports distributed system, and distributed version control, as well as TFVC is having centralized version control. Okay, so that's we'll be able to use into the Git. So if you're going to talk about something called Git, Okay, so if you're talking about the GitHub, so GitHub and just it's trying to compare with the Azure repo and the GitHub. Okay, so if you're talking about the GitHub, GitHub is also open source community driven. Okay, and it's actually stores the code, builds the code. You can have a security of the code. Those things you will be able to achieve using that as well. So whatever you can do with the Azure repos, you can go ahead and do with the GitHub as well. Also, you can link your GitHub with Azure boards. Okay, so just now we have seen Azure boards. So Azure boards, we can plan, track, and discuss all those things. The Azure GitHub also comes with a similar kind of feature. Okay, so Azure GitHub is also having some work item and those information available that you can go ahead and link with that. Okay, and you can pull those information from the GitHub, either using a passing the username password or something called a personal access token. You will be able to integrate your Git with the Azure repos. Another thing you have, if you want to migrate, so just now we have seen the TFVC is something called centralized source control, and Git is distributed source control. Now if you have the old codes available into the TFVC and you want to migrate that into the Git, that is also a possibility which is already available. So there is in the Azure DevOps only, you have something called import repository. So if you go to your project and there is something called new repository and the import repository options are available, you can click on import repository, you can select your source control, and then you just click on that and you can migrate. So when you're migrating it, just you need to consider that whatever code you have, that's get migrated to the Git. Okay, so whatever the source control you have, that will get migrated. The things which is not get migrated, which is a complete history of the code. Okay, so what, who has done the check-in, who has done it's just a mimic of the history will get migrated. So if you see here, so it's saying that we are not migrating complete history. We'll migrate a code, but will not migrate a complete history. We'll have some high level of, you can say, the history of the TFVC, which will get migrated to Git. We cannot migrate a complete old history from the TFVC to the Git. Okay, and if you want to do that, you can migrate your history and you can have a snapshot available for the some period of time, and then later on, once you are established with that, then you can go ahead and discard all those history which is available into the TFVC. So that which you have to consider when you're migrating a old code from the centralized to the distributed.